Alright, hello everyone. Hopefully sound and video is working and all the issues hopefully resolved. I was thinking to update the software for the streaming, but apparently something went wrong and the new software was not really working, so I had to roll back to the previous version. Anyway, so in this video I'll take a look on A2 AC board for 3458A DMM. So this board came from my Ukrainian friend Sergey, and hopefully I'll be able to troubleshoot it and quickly fix it and get it back to him, so he can have his 3458A working and able to calibrate and run all the experiments and applications he needs. So that's the goal of this live stream. And for the testing, I will use my own 3458A unit that I built out of some scrap parts. So essentially you see this black front panel. That is not original ROS brand new instrument, but actually a replacement panel for the HP chassis I had. So I have the actual board. So here it is. This is also HP original board, pretty old. Date code, I believe, yeah, 1996. So Sergey already replaced some of the parts, and it get somewhat functional, but still unable to pass self-test. So right now I have all my boards in the instrument, and I can show you that it's able to measure 1 volt. So 1 volt I measure sourcing from the calibrator. See, it's right behind over there. So this means it's sourcing 1 volt, 1 kilohertz, and the output goes through the coaxial cable to the inputs of 3458A. So I can probably reposition the camera a little bit closer and show you that meters is indeed working fine. So it reads 1 volt. I can go scale up. This is right now set ACV sync, so still we have 1 volt and 100 volt range. We get 1 volt at kilovolt. I like to use 1 volt range and 1 volt signal, just to be able to troubleshoot how the signal goes on AC board. And also, like, 1 kilohertz is not too high, not too low, so we can see like if there is any weird distortions or anything happening electrically. But for now, we can just make sure everything is working fine. So let's try different mode. So 3458A have at least 7 modes of measuring AC waveforms. So analog mode working as well, no problems. And we can try random. Set ACV, random. So also no issues whatsoever, as expected. And I already run the self-test and ACAL all prior to starting the video, and this meter passed since it's already been repaired some time ago. So what we can do is now we can put faulty A2 board and then see how the behavior changes and start troubleshooting. So that's pretty much the idea. Again, this is not a Keysight brand new black edition 3458A, but HP old instrument with old boards, just with the new front panel and new plastic parts, because the original plastic parts were all kind of destroyed and smashed. So, and right now the new parts with the black color actually half the price of the white ones. So that's the reason. Just save some money and get the refreshed look, I guess. But again, this is not a Keysight unit, as you will see when we open it up. So let's reposition a little bit. I already prepared some of the stuff that will help us with the repair. So this is a bill of materials from a clip for A2 board, and here is the actual circuit diagram from the clip. So I printed it out so we can follow the signals, what's going on, and on the back I have the A2 board placements. So there you go. I also have a blank A2 board, so I can show you in a second. So this is the blank board without any parts, in case we need some looking like where the traces go and things like that. But I don't think we will actually will need to do anything with this. Okay. I'm still using my DSLR, so everything is manual focus, manual zoom. This is a 50mm prime lens on old Nikon D800. Okay. Yeah, and the VFD on this instrument is kind of dim, but I don't really care, because the only way I use this instrument is through the GPIB. So don't care if the VFD is bright or not, at least I can see some numbers in there. So let's disconnect the input and take the unit apart. And I actually took the original covers and painted them into the black, so it's kind of matching for the front panel, because the original Keysight covers, they are very expensive, so that's why it looks like kind of strange. So we need the unit doesn't have the serial number, because it was never this set of hardware and boards was never actually made by Keysight, so it's a prototype unit that I use just internally in the lab. It will never leave my lab. It will never get serviced officially in Keysight facilities, so we don't have a serial number for this company. Need to remove the guard cover. So what you can see in here, I'll show you real quick. So I got all the A3 board that I've tested so far. It's minus 0.01 or thereabout ppms per day. So pretty good drift. Again, old A4 board And this is my A2 board, all working, and I actually need to replace these tall caps to something more suitable, because they are kind of touching the cover, but for now I don't really care. So this is the insides of the box, and what we will do, we will just replace A2 board, the faulty, powered it back up, and test what issues we have. So the process is pretty straightforward. Unscrew some of the bolts, remove the guard rod, this guy, and this cable, and that's it. Let's see. I need to pry it a little bit. Okay. I need the right Torx screwdriver. I think I had one somewhere. There we go. Yeah, come on. And we don't need to remove this screw. It just mounts the cover into the PCB. It's not mounted to the chassis. So let's get rid of the push rod. There we go. So that's the push rod used for the guard switch. So that's the original board. It's also HP. Part number 3458A 66502. So that's the board. We will put it aside and put the bad one in. There we go. I'll just put like a couple screws to keep it in place. And now I think we're ready to test it. I'll just keep the meter upside down, so we'll keep all the electrons safe and not fall down. So I should have still enough reach for the, for the cable. Let's power it up. So meter is powered up, and we can take a look. What is it showing? Can probably turn off some lights so we can see the screen better. I think this is slightly better. Maybe I can flip the camera as well. Vertical flip. Yeah, that doesn't quite work because we need horizontal as well. Okay. Okay, let's run the self-test. So the beginning is good. So usually the self-test procedure runs DC ranges first, then switches to, if I remember right, resistance, current, and then AC. So I expect meter would run for some time, and then it will fail. Normally self-test is pretty quick, takes about 140 seconds. And there is the AC test. Ratio is okay. AC DC 10 millivolts, 100 millivolts, 1 volt, 10 volts. I would think it would fail by now. Looks like it's actually passing. So, interesting. That's unexpected. Okay. Let's run a cal, I guess. That's actually quite bad news. Because it might mean that some other board was actually broken in my friend's unit. Okay, well, at least we can test everything and make sure that this A2 board is good. Or not, because it needs to pass a cal. So, interesting. Okay, so Sergey is actually in the chat and saying that it did pass self-test. So we are still not in the confirmed working conditions, so we'll see. I started ACL ACV, ACL all, so it will run ACL DC, then ACL resistance, and then finally ACL AC voltages and ranges. Hopefully, and I was pretty confident that the problem is only on A2. So we'll see. It takes about 860 seconds. And of course, we will need to inject signals and measure in all the AC modes to check if everything is okay. And actually, the orientation of the meter have the A3 and A2 mounted on the bottom. And right now it's inversed, so it's on the top, and the electrons will stay put. Unrelated question. Successful ACAL means short-term stability and parameters are within spec, not sufficient to conclude there aren't long-term stability issues, right? No, wrong. So successful ACAL means that the functionality of ACAL function works. So meter is able to do the transfers internally, but all it needs to be able to pass that is just like couple minutes of stability. It does not mean that meter is stable, and it does not mean that meter will actually meet the specifications. So for all that, you actually still need to spend weeks and often months of testing and careful external calibration. And actually, I'm preparing the new guide about how to repair 3458A and not go crazy. So it's still kind of a draft, but I can post a link in here, so you can guys check it out. So I already explained the drift and stability testing procedure that I use to test all my meters in there. So hopefully it will be useful, because I'm a little bit tired of replying everyone every couple weeks who got 3458A, the very same answers to very same questions. So I decided kind of summarize everything together and put into the article. So there is like, I would say this guide is complete by like maybe 25%. So I don't have much time currently to completely finish it. So it will take some time, but I think there is already some useful information in there. If you actually have found a problem that is not typically commonly known for 3458A, feel free to reach out and let me know. I will add it in the guide as well. So you can always find me and reach to me through the xdevs/contact, and all the like contact information is in there. So usually email works the best. So meter is still running. I don't expect any issues with DC and DCI and resistance, because this confirmed good meter. But I hope to see some AC failure. Okay. Have you thought about writing a book? I thought about it, but I'm not writing a book. It's a lot of work. So maybe someday. I'm more interested to see a book about another instrument. So far I'm still collecting the knowledge about it. And it's also as famous as 3458A in the metrology industry. I don't even actually know what exactly goes into writing and publishing book, like formal formatting and everything. No, it's not 1281. 1281 is a very nice instrument, but I think it's not on the top of the shopping list these days, unfortunately. We can say thank you to Fluke for that. Still running. I think we are only like halfway through the ACAL procedure. And again, like to have a proper ACAL, you would need to have meter all closed up and warmed up for many hours and all that. But right now we just want to see if it fails or not, doing the internal transfers for AC ranges. And Ian had a question, was the problem intermittent? No, it was actually very reliably failing in the camera or the microphone. All right. All this battery is already 12-year-old, so they don't last as long. I have 7 of them. If the mic goes out, just yell in the chat box and I'll be sure to replace the batteries. So my strategy to the troubleshooting and repair was actually connect 1 volt 1 kilohertz signal and probe it at different points on A2 board. For this I have the scope already running over there. Whoop. And then we could compare also to the working board if we needed to. So that was kind of the idea when I was preparing for the start of the stream. That's what I did previous times and usually works. I really like to take very nice high-resolution photographs, so small tiny cameras don't quite cut it for me. So that's the answer to the last question, if I can change the camera. I really like my Nikon, so it's not the best for the video because it's very old, but it works. And you are able to see this stream, so that's all that matters. Nikon actually sells adapter for AC power in the camera, but it's like $200 or something like that for a quite kludgy battery to AC interface. So that's kind of a lot of money for just a few wires and a small board interface there. When was this one made? What exactly made? Well, this 3458A is actually my zombie unit, so it doesn't have a specific date. So you could say it's was made in 2024, because that's when I finally made it all functional and assembled all together. So this is using all the HP boards. I can actually look at the date codes. So we're already in AC mode, and looks interesting. Doesn't fail yet. So the A3 board on my meter is made in, let's see, 1989. A4 is I think 1990s, and A6 1994. So it's all over the shop, but it's all old hardware. Only the front panel, the keyboard, it passed. So I guess that's it for repair. Repair is done. No repair needed. Well, of course I'm joking. So we can put the signal to the input and check if all the other ranges work. So let me put the outer cover first, so I can put the meter into the normal position. Or we can actually move the whole setup closer to calibrator, so we can test all the other ranges with different voltages as well. I guess let's do that. All right, this goes back. So I need to reposition some lights. All right, let's move the camera. So it's a little bit tricky. There we go. So you will be able to see the calibrator and the readings on the meter. There we go. Really nice. So let's plug the cable in. So this is just a simple coax close to the output of the calibrator right there. And I think I can get a little bit closer. Yeah, this should work. Yeah, sorry about this hanging cable, but I guess we can see everything. And video is still good. All right, let's source some signals and see what meter shows. So we can start first with 1 volt 1 kilohertz AC mode, and we get a good reading. So 1 volt, we can try 10. 10 is okay. We can try 100. And I need to force. There we go. 100 volts. Try, let's say nothing too crazy. Let's say 400 volts, still 1 kilohertz. So, reading is okay. You can try go down. So let's try 100 millivolts. Okay, no problem. And 10 millivolts. Try different mode. Set ACV, synchronous. Still same frequency. So let's give it a little bit. Maybe the L filter. There we go. 10 millivolts. Let's try higher range, 100 millivolts. No problem. Yeah, pretty much spot on, 1 volt. Let's try 10. We can try a different frequency too. So we can check the frequency right now. Yeah, 999 something something. So we can try 100 hertz. Back to AC voltage measurement. No problem. We can try 10 kilohertz. A little bit off. 100 kilohertz. Slightly more off, but That's within acceptable ranges for the uncertainty and tolerance. And again, we run the ACAL without any warm-up. So 10 volts, fine. 100 volts. And force the output. There is a safety feature in the calibrator. It will not let you carry over output enabled when you switch to the high voltages for the safety reasons. And it will also continue like a beeping, so you know the dangerous voltage outputs are present at the terminals. So that's really good, no problem. Let's try fire. $500 volts. 700. Yeah, pretty good. We can try yet another mode. Set ACV random. So 1 volt. Let's try 10. Issue. Let's try 100. I think the kilowatt will be fine as well. Yep, and we can try 10 millivolts again. Pretty much perfect. And 100 millivolts. Yep. So, conclusion that we have a good A2 board, I believe. Nothing to repair, unfortunately. Well, that's it. And we can also check the DC just in case. I don't think there would be any issue there. So 1 volt DC, output on. It's fine. So I guess that's kind of a short live stream. Let's answer some of the chat questions. I can give the overview. By the way, if you think I didn't see enough dead A2 boards, so I can show some of the remnants. Sitting in the bench right there. Some of that U180 chips. Let's focus. So that's the typical solution for the drift on 3458 AC. And then I have the data logging set up right there, measuring some stuff. So that's the overview of the lab, I guess. Can put a wider lens. I don't think I have anything secret on the bench, so yeah. Oop. Okay. Let's answer some questions. Okay. By chance, looks like some AC/DC fail. Rojas discussion. How long have you had 4808? That would be 8 years, I believe. But actually, I only had it in physical possession, maybe 5 years. I really like it. Tin, are you still at EVGA? No, I left EVGA in 2019. Check the connections on the board. Okay, I guess not much questions to ask, so any ideas what else we can do? I was thinking about like an hour-long live stream or so, and right now we're kind of cutting it short because there is nothing to repair, and so far we went only about, how long was the stream? I don't see the timer. Less than an hour. So for Sergey, probably the next direction would be to work on A1, because there is nothing else in the signal path that would be causing the problems with the AC voltage function other than A1. Because you have the new A3 board, this A2 board is working. Maybe there was some signal is getting shorted or not getting properly switched on A1. So I think that's the only thing that left. And actually I do have A1 board that is broken. No, that was not the thermal stress, because with Sergey's unit it was failing right away. So, and like it was failing right away, and also the failing exactly the same way after like 1 hour, 2 hours of running. So it's not like some little like borderline kind of issue, but actually a hard fault. So let's try actually different A1, because I did want to swap the A1 board in this unit anyway. I mean my black zombie unit. So I guess it will be a little bit more interesting than just this quick boring test. Dallas wouldn't, even if you have no data at all, like completely blank, ACL will populate all the data, so it doesn't matter what data you have in the Dallas. I mean, for terms of functionality, not obviously the calibration. I think your A1 is problematic. So I have actually a couple of the A1s. So I have, let me show you. All right, camera down. There we go. So this A1 board has a label put by me, bad DCI, value 95 error. So something is broken for DC function. Then obviously I have the one with a burned hole in it. And then I have one good board that it was bad, but I repaired it. So this is the second board. It's actually Agilent board. You can spot those nice, beautiful blue relays. And this board had some of the missing parts. I think it had one small issue, and now it's completely working. So I want to put this board into the meter. All right, A1 is the main board with all the input circuitry and DC amplifier, resistance functionality, all that. So this is the A1. So we can put that one in and see if the error is still the same. But I don't think I'll be fixing it today. All right. I guess we can turn off the scope, since there is no need in it today. There are still a couple of the small items on the board. So I can tell and show what was actually replaced. Probably. I can get a hold of my camera. Come on. There we go. So the replacement parts were Elantex, then these switches DG211, and this guy, I believe this guy, then the JFET dual amplifier, and then this one of the JFETs for switching. It was replaced with the SMT part over there. I think relays were replaced. And that was probably it. So pretty much all the typical common problematic parts were replaced by Sergey before, and it's replacing that JFET actually helped, but it was still failing. So here it doesn't fail. So there are, I guess, a couple of the things I can check on the board, but I don't think it's any problem. I can replace this JFET to see if it's used, the same model is used on the A1 somewhere, and then put a like kind of original part, maybe still from another A1 board, put in there, so it's kind of like original. But other than that, I don't think I can do anything with it, other than ship back to Sergey. An actually interesting experiment is, I see like these posts or the pads for mounting for the screws. They actually have electrical connections as well, because like all this metal casing is actually at the guard potential. So if you don't have the screws in, would it have any fail, like a hardware fail? Let's try that. I'll just remove the screws, lift the board a little bit, so it doesn't have the contact with the metal stud. And we can power it up and run the self-test and check the AC ranges. So I'll just lift it slightly, like so. Can put something thin under, like a toothpick. That will work. Okay. I don't think it would actually make the meter fail, because we still have the connection through the ribbon cables. But we can check. So meter is on. Can see anything? There we go. And the typical issue with the AC board is you have some bogus voltage even when you have input shorted. So let's short the input. There. That's my short. And you can see right away, I'm reading like 0.008 millivolts, so that's 80 microvolts or so. Just some pickup. And then if I go different ranges, like there is some value, but it's kind of small. So that's normal. And if you have a broken A2 or apparently A1 as well, you would have like some values, like maybe like 80 volts when you go to kilovolt range. Let's run the self-test real quick, because it's fairly quick. And Sergey unit was failing like on this when it begins AC tests pretty much right away. So it's already way past that, and again, we didn't wait for any warm-up or anything. All right, self-test pass. So the screws don't make at least the working board fail. But obviously, if you are doing repair properly, all the mounting hardware need to be installed. No question about it. So I can put my own board back in, and we can switch to A1. And then I guess that would be it for today's video. And I'm avoiding to touch any like of the components, just handle the board by the edges or by the tall parts like a relay, so like we don't have additional contamination and things like that. So tricky to get it off that connector. There we go. So that's the board. Need to get into the right spot. There we go. Almost there. Okay, let's plug the guard push rod. There we go. And finally the in-guard cover. I also have the special option cover for the A6. right here. So this was used for the special US Navy meters. It's actually one half, and another half is closing the other side. So we can put the outer cover and then flip the meter upside down. We can test again to check that it's still working, that we didn't break anything. That's always a possibility. There we go. Rear position camera. There we go. I can put like something black. So some less reflection. Helps a little bit, not much. I guess this is good enough. And run the self-test. Are there of this highly sensitive electronic metrology equipment susceptible for damage by the recent solar flare events? Maybe some, but with general purpose stuff, I don't think. Spiral wire device. Yeah, that coaxial PTFE coil is a capacitor, and the main benefit of doing it like that, first, the capacitance is pretty small, and the second is using shielded PTFE piece of coax, so it's pretty stable in the dielectric properties. So similar like delay line out of commercial components wouldn't be as high performing, at least back in the days when it was designed. So that's kind of a very simplified answer to that question. So self-test passed. I don't think there is much else we can do other than do the A1 stuff. So I shorted the input. Okay, so this is kind of the issue that you would have with the broken A2. You can see the input is actually shorted right there. It's there is a shorting plug, but the meter reads 136, so it stays the same value. See, 136, just the dot moves. So this is kind of the typical problem when you have broken. So 135, 136 always stays, and then doesn't matter even if you use kilovolt range. So it shows like, okay, you have 137 volts, but like we have input shorted to to the copper link. So right now it's because we don't have the ACAL done. So the values or whatever ACAL for this board is actually incorrect because we run the ACAL with that another board. So this is actually quite interesting observation, because it means if you are unable to pass ACAL all, you will have the incorrect EEPROM contents for the all the corrections and the flatness deck and offsets. So that would cause those bogus values. So you need to be able to pass ACAL to validate that the A2 board is working. And if you cannot do that, then you have the hardware fault. So this is what is happening with the Sergey unit. Because he replaced the EEPROM and calibration data chip in 3458A unit that he has, because the original Dallas or the Snap had whatever battery backed up chip, they were bad. So he doesn't have the good ACAL data now, and that's why he was seeing those incorrect signals or like the bogus readings. So we need to fix the A1 board, because that's the only board left untested, to confirm that everything is fine. So this is another supporting theory, so to say, educated guess, what's wrong with Sergey's unit. So the readings he had was like 80 something, so 86 volts, 8.6 volts, and so on. Those were not actual measurements generated by A2, but just bad calibration data together with unable to run ACAL all because of some other hardware fault. Okay, this makes more sense now. And I would expect right now, after the ACAL all pass, it will actually show no problems with A2. So, I guess that's some progress. And yet another item to add to the guide. So while it's running ACAL, let's remove the top cover. So I need to remove the screw on the side. Okay. Okay. I need a bigger screwdriver for that bolt. So here we have all the input switching. This connector goes to A3 board, this connector goes to A2 board. Then all the current shunt here. Temperature sensor for 3458A is right here. We have resistance function, current source in here. This is the protection network for over voltage protection for current. Here we have DC amplifier. Here is the LTZ reference. This is a A10 board. This is the front to rear switching board. And we have A4 power supply board. So that's about it, and some digital logic around to control different switching and ranging. Why I can pass a DCV? Because DCV does not use all the ranging and switching available. It's only going to the DC path. So A1 board is also responsible for switching AC signals by separate signal route, signal path, I guess. So I would ship you back the board, relay, some other parts I think you needed, but I forgot. So we'll sort everything out. Yes, that is correct. The problem is with Sergey's A1. So I'm just waiting here till it finishes the AHL, so we can confirm that there would be 0 volts or some microvolts on ACV. If anybody else have any questions about 3458A, feel free to ask. I think it will be running for another maybe 5 minutes. Do the new 3458A still use wire capacitor? Yes, it does. That part didn't change. Mainly, actually, the new 3458A is still using through-hole and deep parts, except those Atlantic comparators. They were replaced with a modern solution with the Texas Instruments high-speed comparators and 5-volt and negative 5-volt regulators around them. Did they change U180? No. They are making the new ones, but I don't think the design itself changed. The chip itself is not... it wasn't the problem with the ROHS. Cotter relays too. Yes, the cotter relays were replaced. I think some of them, not all of them. I'll need to check the photos again, but I think they're using the new version of the relays from another vendor. Let me check. I think Matter relays are popular as well. They have similar performance to Kotos, and they also provide customizable options, like if you need specific contact configuration or higher voltage or better insulation. So if you have big enough volume, you can ask a relay vendor and they will customize the relay for you. So let's see which relays were used. So I guess I can show the photo of the new board. Well, relatively new. It's the unit from 2020. So it's not the latest one, because they also did some changes since 2020. Let's see, there's the photo. And where's the A1 board? Yeah, the A1 board was still using actually Koto relays, at least in the box that I tested. So let me see if I can put the image. And show it to you. So here's the image. So this is a Wash S unit from 2020. You can see all the comparator were replaced with this congregation of parts, and the A2 board. So still using all the stuff, deep through resistors. Some of the caps were changed to SMT. All the black caps remain the same, film caps. You can see the high-speed amplifier was replaced. Mostly all the other stuff is still a lot of through-hole, layout mostly the same. And then there is that capacitor. And the Elantec was replaced with a whole bunch of those SMT parts in the corner. And this is model number 3458A 63522. This is again not the latest, not the very newest board, but the board from 2020. As you can probably see from the chip dates, it was actually made in 2018, week 45. And then the second image I can show is the A2 board. So that's the A2 board, mostly unchanged except moving to SMT parts. A9 board is identical. Here we have new black resistor network. Input amplifier, this is old one. On the new board you don't have this metal cans anymore. It's just OPA to 140 or 140. And then the relays, still Koto relays, custom for Keysight. Some more relays. The resistors are all different for the shunts. And I just hear that meter is finished. Yeah, so, and this yellow U21, that's the temperature sensor that you get reading from when you doing the when you request a temp question mark from meter. So meter is finished, and I can see it showing at 1 kilovolt range shows 1.3 volts. So that looks about right. Let's go back. All right. Bye, Ian. Thank you for stopping by. Let's see if we get the right values. So looks much better. No more 120 or what it was, 136, 126. So ACAL kind of fixed it. And to show you that this is a short, like here's the resistance reading. All right. Whoop. Okay. All the different kind of screws in here. Again, I built this unit out of all the rejected parts and zombie parts. So ay. Whoa, that was a bad idea. Right. I think I removed all the screws already. Yep. And off we go. This is kind of part of ongoing experiment to test the different temperature coefficient from different boards. So I wanted to see if this different A1 board is actually changing the coefficient of the meter as a whole, and by how much. There we go. Okay, I think we're almost done. And last screw. Orange, gray, the main terminals, white and black, yellow, and that's it. And actually these are incorrect. And I think the blue goes to the chassis and the gray goes to the, because here is gray, blue, so gray, blue. Tighten the screws. Oh, one more. I don't think I have a screw for there. Oh, that's okay. I guess we will have no screw in there. Unless I can find it real quick. Yeah, I can use this one. Okay. I think this is it. Everything connected. Power. Yep. Let's power it up. Testing hardware. So replacing A1, let's see what it does. So we don't have problem with AC. Let's try resistance. So we did have changed for resistance. Let's connect 1 volt DC and see what happens. I'll source 1 volt DC from the same calibrator. There we go. So I'm connecting the input to the meter. I actually forgot to buy the black fuse holder, so I'm still using the white one. So 1 volt connected, and that's what we got. Can try 10 and 10 volts. So even with replacing A1 board, we still get spot on for the 10 volts. So let's run a cal. I think this is it for the video, because there is not much else left to show. So thanks to everyone who stopped by, and hopefully you found this interesting. All right, have a good time, and that's about it. All right, bye-bye.